Let's see the numericals based on mole concepts and Avogadro's number. We all know the relation between moles and the various units. The equation is 1 mole will always correspond to gram molecular weight, which will be equal to 6.023 into 10 raised to 23 molecules, which will be equal to 22.4 liters, which is also equal to 22400 cc, that is cubic centimeters, which is also equal to 2 into vapor's density at STP. So all these relations are at STP. Now let's see certain numericals. To begin with it, let's see the first one. Calculate the number of moles of nitrogen in 7 grams of nitrogen. In bracket, the atomic mass of nitrogen is 14. Now let's see the solution part of it. 1 mole of any substance is equal to 1 gram molecular weight of that substance. So the molecular weight of nitrogen will be, nitrogen formula is N2, so N plus N. 14 plus 14 is 28 grams. That means 1 mole will correspond to 28 grams. Therefore, 7 grams of nitrogen will correspond to how many moles of nitrogen? Cross multiply it. What you will get is 7 grams of nitrogen will be equal to 1 into 7 divided by 28. The answer will be 0.25 moles. So the number of moles in 7 grams of nitrogen is 0.25 moles. Let's take one more question. Calculate the mass of 50 cc of carbon monoxide at STP. In bracket, carbon weight is 12, oxygen 16. Now let's see. The same way we will be working out this problem also. We know that 1 mole corresponds to 1 gram molecular weight of that substance, and that will always occupy 22.4 liters at STP, which is also equal to 22400 cc at STP. Now let's find out the gram molecular weight of CO, that is C plus O. So 12 plus 16 is equal to 28 grams. So 1 mole of CO is equal to 1 gram molecular weight, which is occupying 22400 cc at STP. So 28 grams of CO occupies 22400 cc at STP. Therefore 50 cc at STP will have how much weight of CO? Cross multiply it, we get 28 into 50 divided by 22400. The answer for that is 0.0625 grams. So mass of 50 centimeter cube of CO at STP is 0.0625 grams. Let's take the last problem with respect to moles and Avogadro's number. Calculate the volume at STP occupied by 6.023 into 10 raised to 22 molecules of a gas X. We all know 1 mole of any substance has 6.023 into 10 raised to 23 molecules, and that many molecules will always occupy 22.4 liters at STP. So 1 mole is equal to 22.4 liters, which is equal to 6.023 into 10 raised to 23 molecules. Therefore 6.023 into 10 raised to 22 molecules will have how much volume? Cross multiply it. You will get 22.4 into 6.023 into 10 raised to 22 divided by 6.023 into 10 raised to 23, and that will be 2.24 liters. Therefore, the volume occupied by X gas at STP by 6.023 into 10 raised to 22 molecules of that gas is equal to 2.24 liters. Now let's see an example which involves general gas equation, which you must have learned in your lower standard, and the relation with mole and Avogadro's number. The question is, calculate the weight of a substance X which in gaseous form occupies 10 liters at 27 degrees Celsius and 700 mm pressure. The molecular weight of the gas X or the substance X is 60. Now, first and foremost thing, how to solve this numerical? Convert the volume to STP using the gas equation. Initial condition, P1, the pressure given to us is 700 mm of mercury. V1 volume is 10 liters. Temperature was 27 degree. Convert into Kelvin. How will you do it? Just add 273 to it. It will turn into 300 Kelvin. Now, final condition is at STP. So, STP, you have to find out the volume of it. For that, the pressure at STP P2 will be 760 mm of mercury, that is 1 atmosphere, and the temperature at STP is 273 Kelvin. So, we are first going to find out the volume occupied by the substance at STP by using the gas equation, and that is P1 V1 upon T1 is equal to P2 V2 upon T2. Let's take V2 as X. Substituting the values, P1 is 700, V1 is 10, so 700 into 10 upon T1, that is 300, is equal to P2 760 into V2 is X and T2 is 273, that is divided by 273. Cross multiply it, therefore V2 will be equal to 700 into 10 into 273 divided by 300 into 760. The answer comes out to be 8.38 liters. That is the volume at STP. So, we now got the volume of that substance at STP, but we wanted the weight of the substance at 10 liters and 27 degree and 700 mm. So now, how to take the relation? We all know 1 gram molecular weight always occupies 22.4 liters at STP. So, 8.38 liters will have how much weight? For that, first we find out 1 gram molecular weight of that substance, which is already given to us. So, we take 60 grams of that gas X, that is substance X, occupying 22.4 liters at STP. Therefore, 8.38 liters will have how much weight? Cross multiply it. Therefore, 8.38 into 60 divided by 22.4, which comes out to be 22.45 grams. Therefore, the weight of the substance X is 22.45 grams. Let's take one more numerical to find out gram atom and gram molecule. First, the question can be framed like this. Calculate the gram atom present in 8 grams of oxygen. In bracket, weight of oxygen is 16. Now we know the formula for gram atom. Gram atom is equal to the ratio of mass in grams given divided by relative atomic mass. In this case, mass is given to us, that is 8, and the relative atomic mass of oxygen is 16. So 8 divided by 16 is equal to 0.5 grams atom. Let's take it for gram molecule. The question can be, calculate the gram molecule present in 45 grams of water. In bracket, hydrogen weight is 1, oxygen is 16. Therefore, gram molecule is equal to the ratio of mass in grams upon relative molecular mass. Mass is given to us 45 grams. So 45 divided by the molecular weight of water, that is 18. The answer is 2.5 gram molecule. Let's take one more question, one more problem with respect to mole and Avogadro's. The question is, if 100 cc of a gas A contains Y molecules, how many molecules of a gas B will be present in 50 cc of B and of gas C in 25 cc of C? The gas A, B and C are under the same condition of temperature and pressure. The solution for this is, according to Avogadro's law, under the same condition of temperature and pressure, equal volume of all gases will have the same number of molecules. So, if 100 cc of a gas A is containing Y molecule, therefore 100 cc of B, gas B, as well as 100 cc of the gas C will also contain Y molecules. But given to us is what? 50 cc of gas B, that will contain half molecules, that is Y by 2. Whereas C is given as 25 cc, so it will contain 1/4 of Y, that is Y by 4 molecules. Let's take a numerical which involves us to find vapor density and molecular weight. The question will be, a gas occupies 700 ml at a pressure of 700 mm of mercury and a temperature of 57 degrees Celsius. If at STP the mass of the gas is 1.5 grams, find the vapor density and the molecular weight of the gas. Given to us is 1 liter of hydrogen weight is 0.09 grams at STP. Now, how to go for the solution part? First and foremost thing, convert the volume to STP using the gas equation. Initial condition given to us is P1 700 mm of mercury, V1 700 ml, T1 57 degree, convert into Kelvin, 57 plus 273 equal to 330 Kelvin. Final condition at STP, P2 760 mm of mercury, V2 let it be X, the volume which we require to find it out at STP, T2 273 Kelvin. Now, using the gas equation, P1 V1 upon T1 is equal to P2 V2 upon T2. Substituting the values, P1 700 into V1 again 700 divided by T1, that is 330, is equal to P2 760 into V2, that is X, upon T2, that is 273, cross multiply. V2 is equal to 700 into 700 into 273 divided by 760 into 330. The answer is 533.37 ml. 533.37 ml. This is the volume of H2P. But then we want to find out molecular weight and vapor density. So now let's calculate the vapor density and the molecular weight of the gas. We have already found out the volume of the gas at H2P, that is 533.37 ml. Now this 533.37 ml volume of the gas calculated above corresponds to 1.5 grams weight, which is given in the problem. Therefore, 1000 ml of the same gas will weigh how much? We are converting it into 1 liter. 1000 ml is 1 liter. So, it is 1.5 into 1000 divided by 533.37. The answer comes out to be 2.8123 grams. Now, vapor density is equal to ratio of weight of 1000 ml, that is 1 liter of the gas, to the weight of 1000 ml, that is 1 liter of hydrogen gas. Weight of 1 liter of hydrogen gas is given in the problem, that is 0.09, and weight of 1 liter of the gas at H2P we have already calculated, that is 2.8123. Now 2.8123 divided by 0.09, the answer comes out to be 31.25. So the vapor density is 31.25. Now we wanted molecular weight. Molecular weight is twice the vapor density. So 2 into 31.25. The answer comes out to be 62.5 grams. Therefore, the vapor density is 31.25 and the molecular weight is 62.5 grams. Now let's see the second part of the topic. The second part deals with stoichiometry, that is problem involving percentage, problem involving empirical and molecular formula, and problem based on chemical equations. To begin with it, let's see first the problem based on percentage composition. What is percentage composition? It is the percentage by weight of each element in the compound. How we calculate it? Percentage composition is equal to the ratio of weight of the element in one molecule of the compound divided by the gram molecular weight of the compound into 100. Now let's see some problem based on it. To begin with it, the question which might be asked to you people are, calculate the percentage by weight of the following. First, potassium in potassium dichromate. Second, phosphorus in calcium phosphate. The weights will be given to you in brackets. K, that is potassium, weight is 39. Chromium, Cr, weight 52. Oxygen, 16. Calcium, 40. Phosphorus, 31. Oxygen, 16. Now let's take the first part. We want to find out the percentage of potassium present in potassium dichromate. For that, the first thing you have to do is calculate the gram molecular weight of potassium dichromate. Now how to find out gram molecular weight? Which already you know it. Add the weight according to the formula. The formula for potassium dichromate is K2Cr2O7. So K2, the weight of K2 will be 78, Cr2 is 104 and O7 will be 112. When we add all this weight, we will get 294 grams. So 294 grams of potassium dichromate contains 78 grams of potassium. So 100 grams, whenever we take percentage, we have to take 100 grams. 100 grams of potassium dichromate will contain how much potassium percentage? So just cross multiply it, we will get 78 multiplied by 100 divided by 294. The answer will be 26.53% of potassium. Similar manner, we can find it out the percentage of phosphorus present in calcium phosphate. First, let's calculate the gram molecular weight of calcium phosphate. Calcium phosphate has the formula Ca3 bracket PO4 twice. Now, when we want to find out the weight of calcium, 3 into 40 plus 62 plus 8 into 16. Total weight comes out to be 310. So 310 grams of calcium phosphate contains 62 grams of phosphorus. Therefore, 100 grams of calcium phosphate will contain how much percentage of phosphorus? Just cross multiply. So 62 into 100 divided by 310. The answer comes out to be 20% of phosphorus. Let's take one more question. Calculate the mass of nitrogen supplied to the soil by 5 kg of urea. Urea, formula for which is CO bracket NH2 twice. The weights are given to us. Nitrogen weight is 14, carbon 12, oxygen 16, hydrogen 1. First and foremost thing, you calculate the gram molecular weight of urea. That is 12 plus 16 plus 28 plus 4. Total comes out to be 60 grams. Now, 60 grams of urea contains 28 grams of nitrogen. Therefore, 5, since we have taken 5 kg, so 5 into 1000 grams of urea will contain how much? So the answer will be 28 into 5 into 1000 divided by 60. The answer comes out to be 2333.3 grams of nitrogen. That is 2333.3 grams of nitrogen will be supplied by 5 kg of urea. Let's take one more question. Calculate the percentage of water of crystallization in washing soda. Washing soda having the formula Na2CO3.10H2O. In bracket, the weight of sodium is 23, carbon 12, oxygen 16, hydrogen 1. First and foremost thing, add the weight to get gram molecular weight. So Na2CO3.10H2O, the weights will be 23 into 2 plus 12 plus 16 into 3 plus 10 into 18 will give you 286. Now 286 grams of sodium carbonate, that is Na2CO3.10H2O, will contain 180 grams of water of crystallization. Therefore, 100 grams of Na2CO3.10H2O contains how much water of crystallization? So the answer will be 180 into 100 divided by 286, that comes out to be 62.94% of water of crystallization.